Hello students, welcome once again to our channel. Today in this video we are going to see Tamil Nadu State Board syllabus, class 12 physics, unit 2 current electricity, 8th derivation. I mean to say 8th 5-mark question. Come on, let us continue with our studies. How the EMF of two cells are compared using potentiometer. For this, first we need to draw a neatly labeled diagram. Here comes the diagram. This CD is the potentiometer wire, and here comes the battery and key, and here comes the rheostat. The circuit which is just above the wire CD is known as primary circuit, and the circuit which lies below the wire CD is known as secondary circuit. In the secondary circuit, we have a dp-dt switch. In the dp-dt switch, there are 6 terminals. In that, in the above 2 terminals, one cell is attached, one primary cell. For example, a Daniel cell is attached. In the 2 terminals below, that is M2 and N2, another primary cell, that is a Lagrange cell, is attached. And from the terminal N, a wire goes and a galvanometer is attached. Next to that, a high resistance is attached. From there, the connection goes and ends with a jockey. So by means of this jockey only, we are going to find the balancing lengths. So these 2 circuits comprise the potentiometer, and it is labeled like this. The EMF of this cell is E1 and the EMF of this cell is E2. And these 2 terminals are M1 and N1, and these 2 are M2 and N2, and the terminals at the centers are M and N. Now let us see the explanation. Explanation: primary circuit. In the primary circuit, we can find the following things, that is CD potentiometer wire, BT battery, K key, RH rheostat. In the secondary circuits, we do have G galvanometer and HR high resistance, and dp-dt, it means double pole double throw switch. By means of this switch, we can connect the connection either ways. We can connect it to either Lagrange cell or to the Daniel cell. Then M1 N1 and M2 N2, they are terminals. Then E1, E2, they are EMFs of the cells. Now let us see how does this potentiometer work. Working, the cell whose EMF is E1 is connected and the balancing length L1 is measured. Similarly, the cell whose EMF is E2 is connected and the balancing length L2 is measured. And we all know that the principle of potentiometer is nothing but E is directly proportional to L. Therefore, here we are going to take the proportionality symbol and introduce is equal to symbol and then a constant. So here this I into small r is the constant. So here E is proportional to L. Therefore, I have taken this symbol and I have written the is equal to symbol and a constant IR. So E is equal to IRL. Therefore, we can write E1 is equal to IR L1, let it be equation number 1, and E2 is equal to IR L2, let it be equation number 2. In the next step, we are going to divide the equation 1 by equation 2. So what do we get? While dividing equation 1 with 2, we get E1 by E2 is equal to IR L1 by IR L2. This IR and IR get cancelled. So we get L1 by L2. Therefore, E1 by E2 is equal to L1 by L2. By using this relation, we can compare the EMFs of the primary cells by using the potentiometer. So with this video has come to an end. Let us continue our studies with another derivation in the next video.
Like, share and comment and subscribe our channel and click the bell button for more videos. Thank you.